Good morning, I'm good. How are you?
Fine. Can you see me well?
Yes, I can see you.
And hear me?
Hear you and see you very well.
Okay. Now we have some stop in your image. Can you hear me now? Portanto, estudo do teste não aconteceu.
Hello, so here I'm back. Sorry.
Now you see me well.
Yes, everything seems to be working fine.
So I'm sorry. You're already sharing your screen?
Yes, I just started to share my screen. Can you see it?
Yes, very well. Markus, José Manuel is here with me and is going to make a short presentation of you, and then we can start, okay? Is
Very
it
good.
Okay?
Perfect, yes.
Okay, so, and then I will turn the camera to the audience, okay?
Okay, thank you very much.
Hello, Markus. Good morning.
Hello, José.
Okay. Well, let me do a short presentation of the curriculum to the audience in Portuguese, please. Okay?
Okay, yes, sure.
Bom, o professor Markus formou-se inicialmente na Universidade de Salzburgo, onde fez o seu mestrado, dois mestrados, Matemática e Psicologia, e em Ciências da Computação. É neste âmbito que surge pela primeira vez o programa Geogebra, já há muito tempo, já há mais de 10 anos, e portanto é ele o autor do programa. Portanto, o professor Markus esteve depois na Flórida, portanto, em duas universidades, ele esteve como professor convidado e como professor também dessa universidade. Neste momento é o presidente do Departamento de Educação Matemática da Universidade de Johannes, Kepler, de Linz. Muitos de vocês, se calhar, já o conhecem. De facto, é graças a ele que nós temos a oportunidade de trabalhar com um software gratuito e que permite trabalharmos a matemática junto dos nossos alunos e também para outros estudos. Nesse sentido, já foi agraciado com muitos prémios internacionais, ele e o programa que ele realizou, para além de já ter tido a honra de ter sido concedido um doutoramento honoris causa. Well, Markus, I made a little presentation of the curriculum to the audience, and I thank you all your works with Geogebra, with the community of Geogebra in all the world, and all your contributions for our meetings. And now I ask you to tell us something. Okay, thank you.
Okay, thank you very much.
Markus, I'm sorry, I have to ask you something because I forgot previously. Is it possible for us to make a record of your talk?
Yes, of course.
Okay,
Of course,
thank
yeah. Welcome to do that.
I'm going to turn the camera now, okay?
Perfect. Okay, so now I can see you. Hello, everybody. Greetings from Linz. So thank you for the invitation of letting me participate in this way from remotely with your conference. I'm currently sitting in Linz in Austria, where my hometown is now, and where I'm also working at the university. And in Linz we also have so here are some pictures from Linz. At the left you see some members of the Geogebra team here at the university, and at the right you see the Christmas market. Obviously it's not Christmas time, but it's probably the best picture I could find from Linz, so I just wanted to show you something nice. Okay, so today I would like to talk a little bit about GeoGebra in primary schools and middle schools. So for students from age, basically 3, also kindergarten, 3 up to 12. So for kids before they go to the higher grades. And in the beginning, what I would like to do, I would like to show you some examples of materials from our material platform. That's an online website called Geogebra Tube. And Geogebra Tube is a place where teachers and students can share free materials, so they can upload it there and everybody can use it in different languages. And we have started this some years ago, and at the moment there are about 200,000 free materials out there that you can use. And I will show you some examples. So this is the web link in case you don't know it yet, so that's geogebratube.org. And that's what it looks like. When you go there, you can search for materials. And I have just chosen a couple of examples, and there are the links in my presentation, and I will of course also share the PowerPoint with the organizers later, so you can have the PowerPoint presentation. So you don't need to write down any of these long links. You will get them afterwards, of course. So here the first example. My daughter, her name is Ella, and she turned 5 years, and she likes to play with tablets and computers, as I think most young kids do today, because these devices are around us all of the time, and there are lots of nice, apps and ways to play with them. And one day she showed me this material, which she found herself on Geogebra Tube. So I just wanted to show you that, because she's really into horses. So she likes to, read books about horses and look at pictures with horses. And there was a teacher who created this nice animation, which I found quite interesting. So this is a geometric construction, obviously, of a horse created by some teacher, put on there really with the purpose of playing around with that. And here it actually has some interesting features that you can switch it from gallop to this trot thing. So basically a walking horse and a running horse, and you can make it faster. Yeah, so I really like it. So basically that's one way of using dynamic software like GeoGebra, is basically to use these interactive and dynamic examples. Then let me show you something else. One second, it's coming up. Yeah, here we go. So what we also see more and more is interactive whiteboards in schools. So you have an interactive surface, like a very big tablet. Sometimes it's with a projector, and sometimes it's a big TV with a touchscreen. Essentially, you see like this little girl here, she's using that kind of as a drawing tool. And that was also created with GeoGebra. So how was that done? Switch to the next example. So the previous example that I showed you was an individual worksheet, something that someone put up on Geogebra Tube as a single thing. What I'm showing you now is a so-called Geogebra Book. So that's a collection of different chapters with lots of different GeoGebra materials. So we call that Geogebra Book. And this book is interesting because it was created by a 7-year-old boy. So he just used that as a way to collect his favorite applets that he could find on Geogebra Tube. And he just threw them into that book and used it as a way to show that in his elementary school. So maybe let me show you one of the examples that he put in there. And he didn't create the examples himself. All that he did was he created the book, and he used different things that were already available on Geogebra Tube, created by other teachers, created by other students. Let me show you this little example that we just saw in the video. So this is this kaleidoscope construction, which has a very simple idea. So first example, we just have one point that you can move around, and this point leaves a trace. And what's happening here is we have this single line, and then there's the reflection of that point on the other line, and this also leaves a trace. So you can nicely, investigate this symmetric thing. And the cool thing when we're working in such an environment is that we don't have to stop here with one line. We can use the sliders and have two lines of symmetry. For example, like here, and then investigate what would that do if we have two lines of symmetry. And also it has, a nice artistic element to it. So you can combine this mathematic idea of investigating what symmetry means with drawing nice pictures. And obviously, if I increase the number of lines, like here we have 1, 2, 3 lines, then I can also create more interesting shapes here, more complicated shapes. And you can make it more colorful by using automatic dynamic colors, and the color can be changing. These little features which are nice for kids just to increase the motivation and just make things look more pretty. Okay, so that's one example that this student called Jacob really liked. Another example is, of course, to use pictures, like not just do drawings, but you can put a picture in GeoGebra, for example, here in the background, and then we could do some drawing on top of that picture. So, for example, we could investigate here the shape of this leaf and really look at the symmetry and see how well, symmetry is also represented in nature here. So I think that's a nice example where you can do that. Think about architecture. Students could take a picture of a church window or of some signs that they see on the street, or they could take some logos from cars, shapes, all kinds of shapes that are around us, and we can do these investigations by putting them in the background of GeoGebra and drawing on top of them. What else did this student Jacob find here? So this was symmetry, maybe let's go to something else. Shapes and art. That's also interesting in my view. So for example, here there is a nice thing where it's just about looking at shapes and colors and kind of, estimating what would work where. So it's basically a puzzle, like an art mathematics puzzle, I would call it. So here this black piece, for example, would fit up here. So you see, I just have the pieces, I can just drag them around. So again, the way that it was made in GeoGebra, you have this background image, and then there are these little rectangles that I can drag around, and I can just move them into the right places. So again, kind of a little bit of a game, connecting mathematics with art in this case. More puzzles, you can just also do real puzzles, like little cartoon characters, and just basically use GeoGebra as something that it was not really made for, because GeoGebra is a mathematics tool, but it can also be used for simple things like this. And as said, a lot of these materials are ready to use out there on GeoGebra too, and so you can just search for them, search for puzzles, and then you will get a lot of these things. Yeah, for example, also here this clock example, can be used to learn how to read the clock and all kinds of things. Okay, so this was an example from a student who put together his favorite stuff from Geogebra Tube, 7-year-old student. In Austria, we had done, at my university, we had done a project last year with 11 and 12-year-old students, where we tried out the use of tablets in the classroom. So we basically gave them tablets, we had a set of tablets, and we were trying out different kinds of materials on the tablets, what would work with them, and basically asked them what they like, what they don't like, and how we could improve these materials. And the result of this project was also were 2 Geogebra books, like 2 collections for students of age 11. So that's the 5th year in Austria, when they are for 5 years in school, so they're about 11 years old. And for example, here a couple of things with cubes. So what is this? This is basically the net of a cube, so they can cut it out with paper, and then they can fold it into a cube. And basically the software shows how the folding would work. So you can see that here. And the interesting thing is that, okay, this is the standard net that we typically use when we fold a cube, but there are many more nets. So you could also do it this way, not this way, but this way. And in any way you do it, the applet here always shows you how the folding works. So that's also a nice example how this dynamic software can help us to go beyond the single example that we typically would do if we do it on paper only. So we can have lots of examples, and of course we also did that with paper folding. So it's a combination always of having a computer plus doing it on the board, like drawing with chalk, like traditionally, and also with paper and pencil. Yeah, maybe this other symmetry example, as we're still in geometry here. That's also a nice example how software can be used to give feedback. So the question here is, it's in German, it says move the hand with the point to find the axis of symmetry of this square. Okay, so students should move it around and try to find an axis of symmetry. And think about what we're doing here. It's like, I have the paper, so think of a sheet of paper that you're folding. And I will fold in the piece of paper like this, and okay, and here I get the feedback, yes, that's actually an axis of symmetry. And maybe I can find another one, so maybe like this. Yeah, that's also an axis of symmetry, very good. And maybe there's also one here. Yeah, perfect. So you see that the applet can be used by students to try out things and to give feedback. So of course we also wanted to do this with paper in the real world. They should do that, but here they can, investigate such things also at home and get immediate feedback. Yes, you're on the right track. Yes, that was a good idea. Okay, then the second book that came out of this project was for 12-year-olds, so in grade 6. And in Austria, that's a level when we do, for example, coordinates. So when we introduce coordinates in this year. And that can also be very nicely used as part of, for example, a treasure chest game. So it's a treasure hunt. We're looking for the treasure. You have this treasure map, and somewhere in your village. So what we did is we put this picture of a satellite picture, something from Google Map or something like that. So we put that in the background so that students see, oh, that's my home, maybe that's my, the house where I'm living, or that's the school. So it's very important to customize these things. And now they can do a treasure hunt. So here it's at, 8-2. It says the treasure is at 8-2. So I can move this little magnifying glass to 8-2, and yes, here I am. So I found the treasure. Yes, very good, you found the treasure. New search, let's have the treasure in a different place. That's 4-6. And you see where this is going. So basically they can try again, and they get again immediate feedback. And if they click on new search, they get a new position of the treasure. So they can practice until they have the feeling that okay, now I know how to read the coordinates, how to find the coordinates in coordinate system here. Another application is also to use these applets to do simple constructions where you prepare something in advance. Like here, for example, it's a little question for the kids. So you have 3 kids, David, Leo, and Susie, and they are playing football. So where would we have to place the ball so that the ball is in the same distance from all of them? So for example, if they would start to play in the beginning, we want to put it in a fair place or whatever. So where would the ball be? And the thing could be, students could just guess. So maybe I say, well, maybe if I put the ball here, that is like really fair, so it's the same distance from everybody. I can click on solution. Oh, well, I'm pretty far off. Okay, good. So it gives me the solution, but I still don't know how to do that. So why is it here? And then here comes, of course, the interesting part from the perspective of a mathematics teacher. And construct this position with the tools of GeoGebra. So for example, what we could do here, so we could have those connection lines between the kids, which forms a triangle. And we could then look at perpendicular bisectors of such lines, and we would then see that these all meet in a single spot. And yeah, this is the place where it's the same distance, and we can also actually try that out by having a circle. Oh yeah, and then we see, okay, this is really the center of a circle that has the same distance from all 3 kids. So we can then combine, basically, using pictures giving automatic feedback, and also having some kind of constructions inside of the web page. So we don't need an extra software, we don't need to go to a different window, we can have it all embedded into a web page, and I think that's a really powerful way of going to the next level. So that is simple applets like we saw previously, where you don't have to construct anything, you just move a point or you move a slider, but you can have a little bit more advanced things like here where you actually ask the students to do a construction. And you can also use such applets as a way to show them how to construct things. So for example, here, oops, what happened? So here, this is basically like a construction protocol. I want students to do a triangle construction on paper, and this applet is simply showing them how to do it. So here I have my things for the triangle. Triangle has one side with 6 centimeters, and we have 2 angles, alpha and beta. So how do I do the construction? And this basically is showing it to them step by step. But this was also created with Geogebra. So then that's a completely different use, because I don't want students to do any construction on the computer. I want them to do the construction on paper in their notebook. And the computer is just helping them to do that. Yeah, so these were a couple of examples here. Yeah, I think I would stop here with these examples. So you see, there's lots of things online on Geogebra too for such kids. Let's move to another interesting project that might be particularly interesting for you in Portugal, because it's a little bit closer to you. From Spain, there is this Mathematic Infantil project. Maybe some of you have already seen it. And let me quickly go to the Geogebra Tube page of that project. So they have a special page on Geogebra Tube, and I've included the link in the presentation, so you will get it afterwards. And here they have created a couple of nice Geogebra books with specific examples for young kids. For example, here a puzzle book. Let me show you. I don't know. Let's try to solve a puzzle here. So there's this puzzle thing, and I think the way that it works is that kind of have a couple puzzle pieces, yeah, and I just put them together, so that's quite an easy one. So that's one thing that they've been doing, and maybe I will also go to their website, which is also linked from here, because then I can show you a little video how they actually use this in the classroom. And you see they already starting with kids at 3 years old, which is amazing, because when we created Geogebra, in the beginning, I was doing it for high school students of years 16, 17, 18, and then later it moved down to the middle schools, but now there are many people who are actually using it in kindergarten, which is quite nice in my view. Okay, so let's have a look maybe at some of these videos. So my Spanish and Portuguese is non-existent, so I just have to look here at the pictures. But maybe let's go to this one. Yeah, so this, for example, this color train example was created with Geogebra. It's a Geogebra applet, and here we see how they used it in the classroom. Yeah, so that was a little example showing this applet, basically coloring the right places. Another one might be, where was this lovely clock? I can't find it right now. Let's go here. Ah, yeah, here. So I will open this one in Geogebra, so I don't have a video for this one. So this was also created in Geogebra. Basically, just if you click on these buttons here, you get different examples for reading the clock, and the computer here is really used to quickly create different examples. And it was similar with the previous one also, that in many cases you have a button and then automatically it changes the number, so you have infinitely many examples rather than just having one in there. And here it's also different difficulty levels, like this one includes only full hours, the first one half hours and this quarter hours, and I think this one, yeah, down to the 5 minutes. So I'd really recommend you to have a look at this Mathematik Infantil website. As you see, they have 126 worksheets for children from age 3 up to age 10, so for kindergarten and primary. And everything of this is created with Geogebra. All of it is freely available, and it is in Spanish, so a language close to yours. So you may say, well, but I need Portuguese materials, so what should I do with these Spanish materials? I need it in Portuguese for my kids. And I say, yeah, that's right. So there's an easy way to do that in Geogebra. So let me show you that. For example, let's say I pick this puzzle of 5, okay? And I really like this example, and I would like to translate it now from Spanish to Portuguese. So how would I do that? What you can easily do on Geogebra Tube is, when you are logged in, you can make a copy. So I can go here and make a copy of this one. So now I get a copy of this material. And what I can do here in this copy, I can go into the text. So here is some text, which I think is in Spanish, but I don't understand it. So I will now try to translate it to Portuguese, but my Portuguese is not as good, so I will just use Google Translate. So this is some kind of Portuguese. Probably it's wrong, but I will still use it. Just
close.
It's close, so that's good. So I will take this text and put it in here, and now I have a Portuguese version of this exercise. And maybe in here I would also have to go in here. I could go into this one also and change the words. And when I'm done, I just save this. So now I have my worksheet. Let's look at it, and now you see here is this Google translated Portuguese text in Portuguese. So it's very easy to take existing materials, copy them, and then translate some parts of it into your language. In particular, with many of these materials, most of it is pictures, so very little text, so it's usually very easy to use them in different countries. Okay, I just wanted to mention that. Good. Yeah, and then basically that's also the next thing that I want to show you. So there's so much nice materials out there, but how can I create this myself? And is there a possibility also to use Geogebra directly with the children, with these early grades? And I think so, yes, there is. Of course, the students, they will not create this very fancy, complicated construction. Well, no problem, you just take what's already out there. You know, the 200,000 materials from Geogebra Tube, you just take what you think is nice. But sometimes you want students to create their own things, to learn how things work. And I would like to show you a simple example with Symmetry, how you could do that with Geogebra Web. So I will now go to this webpage, web.geogebra.org. Let me go there, web.geogebra.org. So here I am. So this is the Geogebra web application, and we want to do geometry now. So I click on geometry. And by the way, Geogebra is also available in Portuguese. And if I'm brave enough now, I will switch to Portuguese. Language, let's see if I can do that. Portuguese in Portugal. And that means that all of the tools here, they are now in Portuguese translation, as you can see. Okay, so let's do the construction in Portuguese. I think I can do it. So I need a reta. And then what I want to do is I want to do a reflection. So I want to draw a little boy. Let's do very simple, using some segments and circles. I will just draw a little boy. Okay, so here is like a little thing. Maybe I make it a little bit more pretty. I make a red head and head. Okay, good. So now I have drawn this thing, and I can now use a tool called. Can you say it, Lina? Okay. Axial. So this is axial. So I select my little drawing that I did, and I click on the reta. Was it reta? Yes. And so I get this, the mirrored thing of that. And the cool thing in GeoGebra is that it's not just a picture, but I can go back and change the original picture by moving it around. So you see that I now have this dynamic. They can have a fist fight. So they can play with each other, and you can see what it does. Big head and small head. Okay, so they can play with that, and they can investigate symmetry in a very easy way. So you saw that construction. That's something what I just did. You can also do that with students, and you can do it on the fly. So they don't have the feeling that everything comes out of the box and there's no way to create it ourselves. Simple things like this you can create yourself. And if you have created that, then it's also very easy to put that on GeoGebra. I think I might need your help again, Lina. I think Rava is safe. Yes, so let's save. And now I want to save it as Publico. So this means it should be shown on GeoGebra too. I can have it private and only I can see it. But maybe I want to give it to my students, and this is, I don't know, mirror man, I just call it like this, and then save. Good, it's saved, and that is now available in my materials on GeoGebra too. So let's have a look at it. So that's what we just created. We just created this. This is now online under this link. So I have this link now, and I can give it to my students immediately. So that's available, and basically everybody else can also use it if they think that's a nice construction. And the second thing that I wanted to show you, which is also easy to do, is, so this was creating something yourself. Maybe you want to do it with students, or maybe as a teacher you want to do that. The second thing is, if you find nice materials on GeoGebra Tube, how do I collect them together in my own book? So I will just quickly show you how to do that by going to GeoGebra Tube. So I go to geogebratube.org, geogebratube.org. And again, when I'm logged in, oh, it's in Portuguese already, perfect. So I have at the bottom here a button that says Criar livro Geogebra. Is this Geogebra, or how do you say it?
Geogebra Book.
Yeah, sure, but how do you pronounce it, Geogebra in Portuguese?
We say Geogebra.
Geogebra, okay. Criar livro Geogebra. I learned some Portuguese today, that's good. Okay, so I put together my primary materials. I give it a name. Okay, I don't need this, but say I want something for students from 6 to 10. Good. Cover up. And now I have this page where there's nothing in it, it's empty, yeah, but I could add some material. Adicionar material. And then, what is it? Create a new one, I think, and this insert an existing one. So maybe I don't want to create anything new, I just want to put some existing so I can look for puzzles. Oh yeah, there's this puzzle that I've just seen earlier, puzzle 5, where was it? Yeah, here. Maybe I want this puzzle, and I add this puzzle, and then maybe I add another puzzle. Oh no, I like this one also looks interesting. So I can look at it if I like it, go back and I edit. So I can throw some things in here, and maybe that's enough for me now. I just want these two materials, so I'm finished. Just look at my book. So here go to there, livro Geogebra. And so now I have my book with the two applets in here. I can click on them, and the students have this little arrow, so they can go to the next one. So they can play with this one, and they can go to the next one. And then they can play with the bunny. They can do those kind of things. So creating a book in GeoGebra Tube is also very easy. Just create a book and then you just throw in the materials that you like and that you found there. Yeah, so that's basically this part. Yeah, that's what we did, and we created a GeoGebra book. Very good. Yeah, maybe just one thing to mention, I'm not going to do now, but just mention. So in these GeoGebra books, you cannot only put in GeoGebra applets and text, as we've seen, but you could also put in videos. So you can have videos and images together with GeoGebra applets. So you can have a little bit more flexible kind of pages in there. So what else is new? So many of you already know GeoGebra, I guess, and are kind of experts on some of the things that I said. So I want to also tell you a little bit about what are some of the new things coming up, apart from the nice materials that we've just seen. So this is Melanie. She's one of our developers, and she's sitting in the Linz office and working on our tablet apps at the moment. And what we also have released last year is GeoGebra 3D. So some of you may have already seen this. So let me just show a little quick video about what you can do with that. I think the 3D is also quite interesting for primary schools because it allows you to interactively manipulate 3D objects more easily. As said, like with the previous things, what you see here is how something is created. In most cases, probably you would not create it with the students, but you would create it in advance, or you would just take existing materials from the web page and then just use them. So again, there are lots of materials using 3D on GeoGebra Tube. Like for example, here we see this cube, so you can look at the cube and together with the net or intersections. I mean, that's a little bit more advanced stuff, but you see basically how powerful and versatile this is. From showing the simple tube, students can then use the same tool starting basically in kindergarten all the way up to high school to their final exam when they go to university. And that's also what we often hear from teachers, that that's a very powerful thing about GeoGebra, that they can use it across many grade levels. Then also one thing that might be worth mentioning, that when you have such worksheets in GeoGebra, you can also nicely integrate them into other software. Let's say you work with Word or you work with PowerPoint, then you can put such GeoGebra applets inside of Word or PowerPoint. With the latest version of Office 2013, we have created so-called apps. So there are Office apps where you can install a little app inside of Word or inside of PowerPoint, and then it's very easy to put a material from GeoGebra Tube. So you see here on the right side again the search field, so you can search for your material that you have put on GeoGebra Tube and then throw it into Word or throw it into PowerPoint. And the way that it works in PowerPoint, it will be fully interactive inside the page, and in Word you have this little image. So in Word you actually get an image of the interactive construction, and when you click on the image you will get a pop-up window with the interactive applet. So then the students can play with that. But that's also a nice way when you work with Word that you could use Word files or PowerPoint files to give things to students. Some of you may be using interactive whiteboards in the classroom, like for example a smartboard. So for example with the Smart Notebook software, so that's the software that comes with smartboards, we have also integrated GeoGebra into that, so that you can directly insert GeoGebra applets in the page, and it's also connected to some extent with what the page has. So for example, in a page you can have handwriting recognition, so you can write like an equation and then drag it into GeoGebra and then it's drawing it. So that's also maybe just interesting to know for those of you who teach 11, 12, 13-year-olds, where that might already be an interesting topic, that you have some simple equations that you want to be drawn in a software. But other than that, you can also embed any kind of materials from GeoGebra Tube, so all of the nice puzzles and games and symmetry examples that we've seen previously, you can put all of this nicely inside this Smart Notebook software. and you can do your handwriting next to it. So that's a nice combination of having the traditional board with handwriting plus the interactivity of Geogebra inside the same system. So we're really trying to integrate Geogebra in the systems that people use out there, so that it's really easy for them to have. And the last real thing that's missing from our end is the phones. So we already have tablet apps, and of course for laptops and desktop computers. But what's still missing was the phone apps, and we are currently working very hard on an Android phone app, which is already in a beta state. So there's a first version available for some of our beta testers, and we expect that we will make it publicly available this summer around the Geogebra Conference in Linz. So this summer in Linz we will have our Geogebra Conference from July 15 to 17, the global gathering. So I hope that some of you may also be able to join us here. And at the conference we will definitely present the phone app. And one important thing for us with the phone app is also that all of the materials that we have on Geogebra 2 should then also be working on the phones. Meaning that these nice puzzles, these nice things should also be available on the phones. Because what we see is that many of these materials, they can really nicely be used with the fingers on smaller screens also. Like the puzzles, and just moving a point around. That's typically no problem to also use that on the phone. Creating things and doing constructions on a little screen, well, that's a little bit more difficult, but consuming and viewing and using existing materials from Geogebra 2, I think phones will be a very good platform for that, simply because so many of the kids have the phones. So they're so widespread that I think in the future the phones will play a really larger role in schools. I know today many teachers don't really like to see the phones because of course you can do many other stupid things with them, that's true. But if we think about it, if we really want to have an environment where every student has a device that they can use anytime, that has a battery that lasts for a long time, that's not too expensive, that they have with them all the time, that they don't forget at home, then I think the phone is probably the best platform to have. So we will definitely want to be there, and our message is simply, we want to make sure that Geogebra works both on a laptop, on the tablets, and also on the phones, and you can use the same materials on all of these devices. Another thing which is coming up are so-called Geogebra groups, and groups are a way where then you would be able to give exercises and get feedback from students. Like we've seen these nice examples where there are these Geogebra books, and basically what I do is, as a teacher, I give material to my students, they play with it, but I don't really get anything back. So they have to write it down on paper, but in the future what we'd like to have is like a little save button. So, okay, please try to do this exercise, and when you're done, you can press the save button, and I can look at it later, so I can check where the students have actually done homework at home, or give them feedback, help them with a construction where they're struggling. So that will be also a next important step for us with Geogebra 2. Concerning how to use Geogebra, on our website there's a nice tutorial page where we're also trying to use videos and applets together. So like you see as a teacher, if you want to know how to use Geogebra, you can go to our tutorial page, you see a video showing you how the construction is done in Geogebra, and then an applet right next to it with the Geogebra tool, so you can try it out right on the same page, so you don't have to go to a different place. Yeah, so that's basically it from my side. I hope that you will find some of the materials useful. As said, we're going to share the presentation afterwards, so you will have all the links that I showed of the examples previously, and I'm now looking forward to a couple of questions from your end. So thank you very much.
Thank you. Thank you, Markus. I think it was interesting. You've shown many examples, which are, some of them are really amazing, and show us how Geogebra became a really democratic tool, and maybe it's no longer only in your hands now.
That's okay, that's okay.
So I will ask if there is some questions here in the audience, okay? Alguém tem alguma pergunta para fazer? Eu posso tentar traduzir.
The question in Portuguese are fine. My Portuguese is very good by now.
Posso fazer uma? Claro. You can hear Markus or not?
I can. Yeah, I can.
He's going to ask you something.
I have one question. What is your perspective in order to develop some kind of version of the Geogebra more simple for the youngers? I know that in the beginning there is a project with the University of Luxembourg, and they try to make the version more less sophisticated for the youngers. What is your perspective? Is better invest in the applets to manipulate for the pupils, or the problem the software can have a little version for the more early child? What is your opinion?
Mm-hmm. Yeah, so thanks for that question. That's true that in some years ago we had a special version of Geogebra called Geogebra Prime. But we kind of moved away from that for a simple reason that it was a little bit difficult to decide. So what did we do with that Geogebra Prime? What we essentially did is we simply changed what kind of tools are up here. So the toolbar was different. Like some tools we removed, for example, these tools. However, what we found is the problem is that when you want to have only special tools for a certain age group, then it's quite different what you want. So instead of having a special version for a certain age group, because we kind of didn't really know what to put in, because there were always teachers who said, well, but we also need this tool because we want to use this one also with the younger kids. So we always had this kind of mixed feedback. So to answer your question, I think the best way will be to use applets to do that. Because in an applet, you can create your own version of GeoGebra very easily by basically when you change the user interface and you save it as an applet, then this is what you can give to your students. So for example, you could, if you know Portuguese, you could...
Yes. What are you trying to find?
I think this one. Personalized barra de ferramentas, yeah, this one. And then I can change the things, I can, this one, I don't need this. So I can throw this away. Okay, I can throw away things that I don't need. I don't want this and I don't want this, so let's simplify it. Okay, so I've thrown away some things, then apply. So now I have a simpler toolbar. I don't have conic sections and I don't have this other thing. I have a simpler toolbar. So it's very easy to do that, and when I save the file now, or I put it on Geogebra, then this is what the students will get. So our experience was that it's usually better that the teacher then makes the decision what they really need, instead of us, because we just couldn't know for so many different applications what would be the best way to give to primary students. And another thing, so that's number one, use this personalized thing. And another aspect is also, now what we have done is we have created this startup page, which also makes it a little bit easier for people to go where they want. So in many cases, I think when you're in primary or in middle school, people will go to the geometry perspective. So they click on geometry and will do this. So if you go here, you basically have the white sheet and you can start, doing your things. I have a 5-year-old daughter, I said Ella, And when she's playing with GeoGebra, then she doesn't really care about the other tools that she doesn't understand. Because my experience is that in her world as a child, she always sees things that she doesn't know. I mean, there's always new things. Everything for her is kind of new in many times. And she's not afraid of that. So for her, it's not a problem that there's maybe 5 tools that she doesn't understand. She just, tries them out, or she just looks for the tools that she needs. So I was actually very surprised with my own daughter that this idea of taking away things may not be as important anyway as I used to think in the past. But you are the experts on this, so I leave the decision up to you. You have the option to change the toolbar to make it simpler, but we basically didn't really find a good way for everybody, so that's why we kept it open.
Thank you, Markus.
So probably it's more confusing for the adult than for the
Exactly. Yeah, I think I agree. Yes, it was more for the teachers than for the kids. The problem.
Those versions, is it possible to work on them other than online? If you're offline, you're not
Yes,
in the internet, you can
yes.
work with them also?
Yes, so all of the materials on GeoGebra, let me show you, for example, here. I had this book, okay, which I really like. I like this book, so I can always go back here to the material page if I click on Created with GeoGebra. So here I'm on this overview page, and here there is something for, is this download? Yeah.
Yes.
Descarregar. And then I can get an offline file of the entire book, not just a single worksheet. I can get all of the materials offline and put it on a stick and carry it into my classroom. And also GeoGebra itself, also this web version, which is in a web browser. So you think you would have to be online. You don't have to be online for this to use that. You can also use this offline. For example, if you have a Chrome browser, Chrome Store, GeoGebra, in the Chrome web browser, they have these Chrome apps, and so here I'm in the Chrome App Store, so you can install GeoGebra in the Chrome browser, and then it will also be offline. So this is in German here, sorry, but it says this will be used offline after you install it. So you basically just once you have to be online to install it on your computer, like your laptop, but then you take it with you, and then it will also work offline, even if you don't have internet at your school. Yeah, that's very important for us. I fully agree that all of these things, they should work offline also. Good.
Mais alguma questão? Okay, Markus, there's no other questions, so I thank you again for your talk. It was very interesting for us, very enlightening. So I think all of us are really inspired by your work, and we'll try to use them as well as we can.
Okay, thank you very much, all of you, for listening, and I hope that there will soon be some cool new primary materials and consequences on GeoGebra to look forward to that, to be looking at them. And actually my daughter will also love to try them out, so maybe you can tell me.
And I suppose she will use it also in Portuguese.
Of course, no problem.
Thank you so much.
Thank you. Bye-bye. Have a good day. Bye.
Só queria deixar uma mensagem. Relativamente ao uso do GeoGebra para os mais novos, a grande questão não é tanto a tecnologia das aplicações, porque quando precisarem de ajuda, de certeza que eu e algumas pessoas que trabalham comigo vos será dada. É criar o corpo de conhecimento que está na nossa mão nos docentes. Um dos grandes problemas dos materiais do GeoGebra é a sua validação relativamente às aprendizagens, não é? Portanto, o primeiro projeto que se tentou desenvolver na Universidade de Luxemburgo, de tentar criar um conjunto de... No fundo era desenhar qual era o ambiente, o micromundo, portanto, está relacionado com aquelas histórias todas do Bob, etc., todo o desenvolvimento dos programas a nível de computação e, portanto, a sua aplicação ao ensino. E, portanto, o Bob foi um dos primeiros que começou a iniciar nas camadas mais jovens, é perceber como é que se vai desenhar o output. O Geogebra teve uma grande mudança nos últimos 2, 3 anos, porque está condicionado, já não é com a tecla. E como vocês já viram no exemplo de Markus, está condicionado com a utilização do dedo e, portanto, os tablets e agora os telefones. E isto criou problemas. Por exemplo, porque é que eu, a professora Ana e outros como nós estamos a fazer coisas mais complexas, não usamos tanto algum tipo de aplicação de touch, porque elas não são tão sensíveis à minúcia. E, contudo, a grande questão com os jovens e com os mais pequeninos é exatamente uma das primeiras questões que se coloca com crianças do primeiro ciclo e mesmo da pré, é a questão de coordenação motora. Portanto, e estou a falar para uma plateia que muitos deles sabem melhor isso do que eu, apesar de eu achar que também sabem uma coisa. E, portanto, essas questões têm de ser colocadas em cima da mesa. E só vos dou um pequeno exemplo. Relativamente à questão que se passou na Espanha. A Espanha existe, eu até vos posso depois enviar o link, um conjunto de materiais nos CDs foram criados pelo Ministério de Educação por uma equipa de excelentes geojuristas, como eu costumo chamar, que estiveram a trabalhar durante 2 anos para o Ministério da Educação a produzir applets e produziram cursos de formação online. Aqueles que tiveram mais insucesso não foi porque as pessoas não se dedicavam, foi por causa do grau de tecnologia que era preciso desenvolver para criar-se boas aplicações, foi exatamente aqueles que pretendiam formar professores da escola primária, ou seja, do primeiro e segundo ciclo. Porquê? Para tornar as coisas simples para o utilizador, é preciso um desenvolvimento muito grande técnico por trás. Porque se nós queremos que um aluno pequenino faça uma pequena seleção, já temos que escolher um ponto maior. E temos que dar a possibilidade de que naquela não faça aquela escolha. Então eu preciso saber programação para depois programar a aplicação. Daí que haja um grande esforço por criar bons materiais, mais ou menos, como ele diz, tipo em applets, e que se faça a conjunção de esforços, porque o Geogebra não é mais tentar essa conjunção de esforços para que existam aplicações já realizadas para determinados tópicos e as pessoas as possam integrar. Aquele exemplo do Markus da integração, do próprio aluno faz vários exemplos que servem para ele aprender aquele tópico, porque no fundo é um exemplo de tentar ultrapassar esta dificuldade, ou seja, quanto mais elementar é o grau de ensino, mais por vezes temos que dominar o software para tornar as coisas simples para quem usa. E, portanto, o esforço de simplificação, como em todas as áreas, é um esforço por vezes colossal. E eu deixava aqui um desafio. O desafio é que, em vez de trabalharmos sós, uns em cada ponta, podemos criar um grupo de trabalho e que não é para criar os materiais todos, é tentar ver o que é que há. Por exemplo, até construir um Geogebra Book. Claro, dizendo, o material foi construído por tal, portanto, se o material foi construído por tal, é uma primeira versão. Nós sabemos fazer isso bem. E esse desafio que eu deixava aqui. Mas se todos colaborarmos um pouco, e estou a falar que todos colaboramos, porque estou a pensar em 2 instituições especificamente neste momento, que estão aqui representadas, a Escola Superior Politécnica de Lisboa, a Escola Superior de Educação do Porto, do Politécnico de Porto, podem fazer, de facto, e não é preciso muito, basta pegarem, eu lembro-me quando foram viajar em matemática e mesmo nos outros programas de desenvolvimento de formação no nível local, também houve outros sites, esses sites que ainda existem, os materiais ainda existem, podem ser adaptados, coligidos e colocados à disposição dos professores. Não é preciso fazer de tudo. E relativamente à personificação digamos assim, da barra de ferramentas, eu na última sessão vou fazer e vou meter algumas ideias para vos mostrar como é que isso é simples e pode ser uma mais-valia, mais ou seja, para focalizar os alunos relativamente para determinado tipo de tarefas, porque se eu lhe ponho um número menor de opções, eu até posso condicionar a trajetória de aprendizagem do aluno no sentido dos conteúdos que quero ou não desenvolver com eles à comunidade. É só este comentário.